Hi, this is Mr. Thill coming to you with another math video. Today we're going to begin progressing past multiplication and into the realm of division. The good thing about it is that division and multiplication are, as I say in the title here, they are related. In fact, multiplication and division, these two operations, are what we call inverse operations. Inverse operations basically means that the operations perform opposite functions. So in multiplication, in that operation, you're taking parts and repeating them until you get a whole. In division, you're reversing the process. You're starting with a whole and you're dividing it into equally sized parts. So we call them inverse operations because they relate to each other, almost in the same way that addition and subtraction relate to each other. So what we're going to look at today is how we can show that multiplication and division are indeed related. And I'm going to do that by taking this part here, or these equations here, and I'm going to go ahead and model how we can take the equations and then take our multiplication models and then use them to show our division. So this set of four equations is called a fact family. And fact families are basically made by applying inverse operations to the same numbers or factors. So we're going to go ahead and take this fact family of 3 times 6 equals 18, and we're going to use our multiplication models to prove that division is related to multiplication. So what we're going to do first, I'm going to go ahead and build this first equation. 3 times 6 is 18. I'm thinking of that as 3 groups of 6. So I'm going to draw 3 groups of 6. So there's one group of 6. Here's my second group of 6. And as you're building your array, try to keep them as organized as possible, especially since when you're making that bridge between multiplication and division, organization is very important. Okay, so this array shows 3 groups of 6. 1 group of 6, 2 groups of 6, 3 groups of 6, and that will total 18. Okay, now as we know from our previous discussion, if I take this array and rotate it, that models my second fact family of 6 times 3 equals 18. So 6 groups of 3. But I'm going to go ahead and model the process of division just using this first array here, because according to commutative property, this array can represent both of these problems, this one and this one. Okay, so when you divide, you're basically reversing the multiplication process. In multiplication, when I multiply my two parts together, I ended up with a whole. In this case, 3 times 6 was 18, and 6 times 3 is also 18. So in division, you're going to take your whole and you're going to partition or divide it into equally sized groups. So my product in multiplication becomes my first number in my division, and this number is called a dividend. So my product becomes my dividend in division. So 18, that's my whole, and that's represented by this whole array right here. When I divide, it says I'm taking 18 and dividing it into 3 equally sized groups. When I look at my array, I can see that there's 3 rows. So each of those rows has the same number in it, number of objects in it. So to model this division, I could take my whole, my 18, and divide it into 3 groups, with each row becoming a group. Then when I count my groups, I can see that each group has 6 in it. So 18 divided into 3 groups gets me 6 objects per group. Okay, let's go ahead and model the last part of our fact family. In this one, we're taking 18, we're taking our whole, and we're dividing it into 6 groups. So when I look at my array, well, what do I have 6 of? I don't have 6 rows, but I do have 6 columns. I'm going to go ahead and take my array here, my 18, and divide it into 6 columns. 1, 2 columns, 3 groups, 4 groups, 5 groups, and 6 groups. Then if I count the number for each group, I can see that each group has 3 in it. So 18 divided into 6 groups is going to be 3 per group. So the fact that I could model the division and the multiplication using the same array shows you that these two concepts or operations are related. When you multiply, you get your whole. When you divide, you take your whole and you partition it out or divide it into smaller, equally sized groups. So that's what we mean when we say inverse operations. So until next time, this has been Mr. Thill with a math video. Thank you.